Assalamualaikum and salam sejahtera to all panels. My name is Muhammad Akil Alimin bin Muhammad Izwan, a bachelor degree student under supervision of TS Dr. Azin Hani bin Abdul Rashid. Today I would like to present my bachelor degree project with title Numerical Simulation of CROSS-PLY RPET and Epoxy Laminated Composites subject to quasi-static indentation test. The outline for my presentation will be first abstract, followed by introduction, literature review, methodology, results and discussions, conclusions and recommendations, and lastly, references. Abstract. The aim of this study is to investigate the impact behavior of RPET and epoxy laminated composites subjected to quasi-static indentation by conducting a numerical simulation. Numerical simulation provides a way to solve problems quickly and easily compared to analytical solution. FE model was first designed using design modeler, and the material for the RPET and epoxy was defined in ANSYS Composite Pre-Post SEP. And lastly, the numerical simulation was simulated using FE software, ANSYS Static Structure. From the result obtained in the simulation, the energy absorption of composite panels from simulation was higher than the experimental, and the damage was more severe. The results has contrast finding because of the FE model was simplified to save the computational time. Introduction. Polyethylene terephthalate PET was widely used because one of the most popular thermoplastic that is frequently employed as a reinforcement material in laminated composites due to its lightweight and high strength qualities. One of the examples of PET is plastic bottle. However, particularly waste material from plastic bottle should be reduced and recycled to avoid more environmental pollution, which has become an issue to global warming. Therefore, many researchers attempts on using RPET as composite material to study the mechanical behavior of this material. One of the methods is study the quasi-static performance on recycled polyethylene terephthalate RPET and to understand the underlying characteristic of RPET as reinforcement material. Finite element analysis (FEA) was another method to investigate the impact behavior of composites by conducting a numerical simulation to obtain detailed information about dynamic response without the need to spend considerable time and resources with cost-effective and efficient tools. Literature review. Based on this table, shown several research that has been studied the quasi-static indentation by using numerical simulation method. This study is selected and put in the literature review as the guideline for my research. The researcher using different kind of software including SolidWorks, Abacus, ANSYS, and LSDINA. Methodology. This is the flowchart showing the methodology for conducting the numerical simulation. First, the FE model was designed in the design modeler. The RPET mat was modeled as a single plate structure with dimension 100 mm square. The geometry model was shown on figure above, consists of 12.7 mm diameter hemispherical tips, indenter, and a support feature with 127 mm square opening for simply support the configuration. Model from design modeler was then transferred to ANSYS Composite Pre-Post SEP to define the material on the plate. Before, the model was designed as a single layer. Therefore, in the SEP, the model was assigned as 4-ply layer RPET and metric epoxy was used to bind the material. The stacking sequence for CROSS-PLY RPET laminated composites was defined in the stack-up properties in SEP Pre-Post as CROSS-PLY orientation with angle 0 degree, 90 degree, 0 degree, 90 degree. After defining the material properties, the design was then transferred into ANSYS static structure to begin the simulation. The accuracy of the output result was depend on the quality of the mesh. Therefore, general mesh was formed on all of the body, and phase meshing was employed into the area of contact between indenter and output panel. Then the boundary condition was defined by putting a constant velocity for the y-axis on the indenter with 1.27 mm per minute and moving only on y-axis, so it cannot move on the x or z-axis. Fixed support was applied at the side of the output panels to prevent all degrees of freedom from moving. After that, we run the calculation and wait for the result. After that, we run the calculation and obtain the result. Okay. Results and discussion. Figure above shows two-line graph from the simulation and experimental result. The stacking configuration of output and epoxy laminated composite with material ratio 6:1 was selected to compare with the numerical results. The sample configuration of output 6:1 shows the highest maximum indentation force and total energy absorption among the other samples as stated in the table. The validation of FEA simulation results were performed by comparing the present study by selecting the highest of the maximum energy absorption in the experimental. Therefore, the sample was selected as the best result to obtain from the experimental. The experimental energy absorbed is obtained by calculating the area under the experimental force and displacement curve using the trapezoidal method of integration, whereas the energy absorbed by the FE model is the model total mechanical strain energy. The result from the simulation were expected to have similar result from the experimental. Table shows the table data from the experimental and the simulation. The simulation test of laminate composites output which hold higher maximum indentation force compared to the simulation. Compared to the experimental. The total energy absorption for simulation was also more than the experimental. The different result between both simulation and experimental happened due to the configuration of parameter setting in the ANSYS. The FE model was modeled as a single plate rather than the original model, which is 5 mm strip unidirectional mat in the design modular. The original model was too complex and it takes a lot of time to do the computational results. Therefore, the model was simplified into a single plate and was defined as 4-ply layer mats with different orientation order to save the computational time. The damage assessment of the reinforcement of the reinforced composite was carried out by observing the laminated composite surface. As we can see, this figure shows the result from the experimental and simulation, and it shows the total deformation of the sample involved of the experimental in my left hand side and simulation on my right hand side. When comparing the deformation from experimental with the when comparing this deformation from experimental with the simulation, we can see the deformation occurs at the center of laminated composite. However, a bulge can be seen in the experimental result, which distort the output surface and form a ring crack. From the simulation, we can see the deformation of the output panels was definitely higher than the experimental. In short, the size of this deformation damage can be seen clearly in both experimental and simulation. However, the damage was more severe compared in the simulation of quasi-static indentation loading because of the large deformation compared to the experiment test. Conclusion. This project was conducted by numerical simulation on quasi-static indentation test on laminated composite of rPET and epoxy. The analysis were made by using software ANSYS R2 2021. The data for this project was obtained in terms of energy absorption and damage assessment. Recommendation. There are 3 recommendations for this project, which is first, for the simulation with different setup for the indentation. We can use different velocity and different indenter tips. Second, increase the stacken configuration for laminated composites. And lastly, obtain more accurate data for material properties. Okay, this is the references I used to study this project. Other references are shown in my report thesis. Okay, that's all for me. Thank you.